Welcome, everyone. Today, we're diving into a brilliantly designed strategy for statistical success. If you've ever stared at a dataset completely paralyzed by the sheer number of statistical tests out there, well, this explainer is exactly what you need. We're going to break down these 5 clear steps for success. We're essentially demystifying the decision-making process for the Friedman test by walking through a super practical, step-by-step path. So by the end of this, you're going to know exactly how to navigate your data's unique quirks. Let's get into it. Here is our agenda, mapping out our 5 steps for success. We'll start with the path to success. Step 1 covers related observations. Step 2 is condition count. Step 3 is rank-based data. Step 4 looks at missing data. And Step 5 wraps up with post-hoc analysis. Kicking things off with Section 1, the path to success. This is our complete step-by-step guide to finding out if the Friedman test is actually the right fit for what you're doing. It literally takes this complex, sometimes anxiety-inducing decision and turns it into a super simple series of yes or no questions. Plus, it gives us these handy off-ramps just in case our data doesn't quite fit the strict criteria. But hey, before we take a single step down that path, we absolutely have to establish a crucial point. Design comes before distribution. Seriously, this is our foundational philosophy here. Before you even start sweating about the mathematical distribution of your numbers, you've got to understand the fundamental design and architecture of your study. Because frankly, if you don't know how your study is built, you can't possibly choose the right tool to analyze it. Moving right along to Section 2. Step 1. Related observations. This step requires us to look really closely at the fundamental nature of our data points. Remember that golden rule we just talked about? Design comes first. Well, this is where we actually analyze that design. We aren't even looking at the raw numbers yet. We're looking at where they came from and how they connect to one another. It's kind of like tracking a single group of patients and measuring their blood pressure over 3 different months. So, the very first question you've got to ask yourself is, are these observations related? You need to answer this to even start the engine. Are you measuring the exact same subjects across different time periods, like those blood pressure patients? Or maybe you're matching participants based on specific traits. Basically, if your observations share a fundamental link, if they're related, you stay on the path and move downward to the next step. All right, Section 3, Step 2, Condition Count. Okay, so we've established that our observations are related. Awesome. Now we're building our sequence for success by verifying the number of conditions in our study. We're essentially layering our criteria here, narrowing down the possibilities with every single successful step we take down this path. And that brings us to our next major decision point. Do we have 3 or more conditions? Think back to our patients for a second. Are you comparing a baseline, a midpoint, and a post-test? Or maybe you're looking at 3 completely different but related treatments. The actual quantity of conditions is the gatekeeper at this stage. Right here is where we hit our first potential detour. If you answer yes to having 3 or more conditions, great, you safely continue down the path. But if you answer no, well, you've got to take the exit ramp. You're directed straight over to the independent group method instead. And honestly, this instantly saves you from wandering down a statistical dead end. On to Section 4, Step 3, Rank-based data. Just tracking our progress for a second, we have ticked the boxes for related observations and for having 3 or more conditions. So our third milestone focuses on whether our analysis is ordinal or rank-based. We're getting highly specific now. The absolute crucial point here is confirming your data fits these specific ordinal or rank-based criteria. Are you dealing with data that naturally falls into an order, like survey responses ranging from strongly disagree all the way up to strongly agree? Or are you maybe ranking outcomes from first to last? The Friedman test really thrives on this specific type of analysis, so your data absolutely must align with it if you want to proceed. Once again, a no means we're taking an alternate route. If your data isn't rank-based, you're guided right off our main path and pointed towards a paired test for 2 conditions instead. And again, this is based entirely on your study's design. Now for Section 5. Step 4, Missing data. Let's just recap this incredible momentum we've got going. By successfully answering yes to related observations, yes to 3 or more conditions, and yes to an ordinal or rank-based analysis, we finally arrive at our target destination. But notice the phrasing here. It says the Friedman test may fit. It doesn't say it will fit. Because even when everything looks absolutely perfect on the surface, there's this specific, kind of hidden obstacle that could still derail us at the very last second. And that obstacle really comes down to these 2 specific terms: missingness, or covariates. If your dataset has missing data points, like let's say one of our blood pressure patients just flat out missed their month 2 appointment, or if you have covariates, those other variables that could be secretly influencing your outcome, well, this specific terminology dictates a massive structural change in our plans. So this is our final critical detour. If you have standard, complete data, then congratulations. The Friedman test fits perfectly. Go for it. But if you encounter missingness or covariates, you are immediately redirected away from the Friedman test and into a mixed model instead. Doing this ensures your analysis remains incredibly robust and accurate, even when your data gets a little messy or complex. Bringing us to Section 6, Step 5, Post Hoc Analysis. Now, getting a significant result might feel like you've reached the end of the road, right? But a significant result is absolutely not the finish line. It still needs post hoc analysis to locate the pairwise differences. See, the Friedman test is just going to tell you that a difference exists somewhere among your 3 or more conditions. It won't tell you where that difference is. To actually locate those specific pairwise differences, like to know for sure if month 1's blood pressure is truly different from month 3's, you absolutely must do the post hoc analysis. It's non-negotiable. And there you have it. Having carefully navigated these 5 structured steps to success, respecting your design, checking your relationships, counting your conditions, verifying your data type, and accounting for any missingness, you've reached the end of this explainer. The only question left is, now that you have the exact right tool in your hands, what fascinating insights and hidden differences is your own perfectly tested data just waiting to show you?